Hello geometers and general seekers of truth. Welcome to the continuing series here on geometric constructions. And remember, we want to do our constructions here with the only tools in our hands are a compass and a straight edge. Okay, so those are the only two things that we really should be using for these constructions. So this question asks, construct a line parallel to the one below that passes through point P. So this is really an illustration of Euclid's fifth postulate, and we'll see that once we complete this construction and prove why it's true. Now, just so that it's a little bit easier to explain, I am going to give these this line here a name. That's line L. Okay? And in order to use parallel lines, if you recall, we know that lines are parallel if there's a transversal through them and there's some sort of properties to the angles that the transversal makes. So what I am going to start with here is my straight edge, not my ruler, but my straight edge, and I am going to create a transversal. So there is my transversal. So construct a transversal. We will call this line M. And we will, wherever the transversal and line L intersect, we will label that angle 1. Okay? So now we have a line passing through P and passing through L as well. That's not the line we're looking for. We want something that is parallel to line L. But we can create such a line simply by applying what we know about corresponding angles. If we replicate, or if we copy angle 1 at point P, then we will for sure have a line that's parallel. So I'm just going to go through the construction with you, and then afterwards we'll look at and see why it works. So the first step here is I am going to set my compass on the vertex of angle 1 and then draw an arc there. Okay. And then I am going to take my pencil and I'm going to name where the arc intersects the two lines. I'm going to name this point up here point A. I'm going to name this one down here point B. Okay? And one thing that should be abundantly clear is that these two here are congruent. Let's call this point Q. So QA is congruent to QB. Now, that's not too important, but it's a fact that we're going to put down. Now what I'm going to do is transfer the needle of the compass to point P and draw a congruent arc, or draw another arc, okay, of the same radius. Maybe this arc isn't congruent, but at least it is the same radius. And you can see here that point P corresponds to Q. This point right here, which I will call C, corresponds to point A. So this segment and PC, our other segment, correspond to each other. And now all we have to do is figure out where to place the corresponding point for B. Well, it's a little bit difficult because B could appear anywhere along this arc, right? And we don't want to just eyeballing it. Eyeballing it is not what geometers do. So we're going to use this other technique where we are going to take advantage of the fact that we know that A and C are corresponding, and we know that B must be a fixed distance from A. So I'm going to set my compass like so, with the needle point on A and the pencil point on B, and then transfer it over here to point C with the needle on C. And I will construct this arc. And you see where the two arcs intersect is where I am going to place the corresponding point of B. So let's call this D. And now taking my straight edge, placing it on P and D. Sorry, my line got a little bit sloppy at the end here. Kind of got away from me, so I'm going to give that another shot. And I'll call this line N. And I'll call this angle 2. Now, we can say a few important things. Angle 1 and angle 2 are corresponding angles that have been cut, that have result from two lines cut by a transversal. Okay? Angle 1 and angle 2 are corresponding angles of two lines that have been cut by a transversal. The other fact that we know is that angle 1 must be congruent to angle 2 by construction, because we made it that way. We copied angle 1 and angle 2 in order to make angle 2. Therefore, by the corresponding angles postulate, line L must be parallel to line N. Right, so, to review, we made a transversal. We called that M. That produced an angle here. We call that 1. And then using compass and straight edge, we copied angle 1 right here to angle 2. And we know for a fact that these two angles must be congruent because we made it that way. Therefore, these two lines have to be parallel by the corresponding angles postulate. So in this example, I hope you can see that we've used our construction tools, our construction skills, along with some understanding of theorems and postulates in geometry in order to construct a perfectly parallel line to another parallel line. Thank you for watching, and as always, ask for help if you need it. Have a wonderful day.